I'm Guillaume, French cybersecurity researcher. I'm known for my work on Scapy. If you don't know, that's a Python library that is really convenient to manipulate packets on the network. The main lead maintainer is Gabriel Potter. He's working really hard on releasing the new version, 2.7.0. So if you have nothing else to do over the weekend, please go on GitHub, get the release candidate and test it. Another advertisement, I'm the editor-in-chief of a French cybersecurity magazine called MISC, which also happens to be one of the sponsors. If you are willing to write an article, please reach out to me or Denis over there, because we are always looking for articles. And these days I'm working for Git Guardian when I look for secrets in what we call unusual places, or we try to find secrets in many weird places. For us, a secret is like a key to the system, like a token or credential. And what we do with my colleagues in the lab is to observe the attacker's behavior when it comes to secrets. And when we check state-of-the-art or regular attacks and leaks, we come to this conclusion of attackers going after 6 big categories of secrets. So nothing new. They will look for source code in GitHub, GitLab, data in buckets like S3. They will also try to access your databases. Your registries could be Artifactory, Docker Hub, NPM, so mainly that's a support for supply chain attacks. And attackers, they will also go after cloud-rated secrets for AWS, GCP. And my key question today is why not having a look at Kubernetes? So that's mainly why what we will focus on today. One of the possible way of putting what attackers are doing is use a MITRE attack path. So one possible scenario, an attacker will go after your secrets in a control registry like Docker Hub. So the T1078 valid account, in that case, that's just a default account. Then you will list 4 registries, get more containers, get hard-coded credentials, and finally access your Kubernetes clusters with valid accounts, modify, so do a deployment, and do some resource hijacking. So it looks a bit weird, but that's also a starting point for the talk. 2 or 3 years ago, there is a researcher doing threat intelligence that shows that attackers are indeed going after these secrets, Kubernetes secrets, to deploy malicious payload on the clusters. You have a link here on the right side. So this is not only hypothetical. In the wild, people are going after Kubernetes secrets. And that's indeed with this scenario in mind, that's my research quick questions. So first, are the Kubernetes clusters publicly accessible? It looks to me like it's a really bad idea to do that, but we'll have a look at some data. Next question is, what are Kubernetes secrets? Is it possible to actually detect them? Are they publicly leaked in Docker Hub, in GitHub, or other things like NPM packages? And finally, what is the impact of these leaks? I need to add a disclaimer. I'm not a Kubernetes expert. I did some deployment on my own, but I'm not, I will say, a Kubernetes pen tester. So I will try my best to give you good recommendation and possible attack scenario. But correct me if I'm wrong. I will take a question after the talk. If you don't know what is Kubernetes, there is a single sentence that is good enough. That's from the documentation of Kubernetes. That's just a platform that you can use to deploy and manage applications. And these applications are stored in Docker images or containers, and that's everything we need to know about Kubernetes. That's a cool black box doing everything for you when it comes to deploying applications. I still need to show the architecture. So that's just a figure I got from the Kubernetes website. And because I'm a super designer, I put some emoji on top. The logs basically mean that you have authentication and encryption, so TLS between the components. You have one big component in Kubernetes, which is called the control plane. It's like a brain. So you will talk to the control plane as to deploy your application, and the control plane components will talk together and make your workload executed on the nodes. The nodes, they are basically physical servers, virtual machines, they are Linux boxes. You are the developer here. You have a key, and this key allows you to talk to API, which is called Kubernetes API Server. It's basically TCP service getting requests and then doing smart stuff in the cluster. So you have one key to talk to the cluster. In the other end, that's why I did this wonderful design. There is one piece of the cluster that is always forgotten, which is the container registry. The goal of Kubernetes is to execute containers, so at some point in time, you need to get the containers from one place. So in that example, that's Docker Hub. And the Kubernetes clusters, they manipulate credentials, usually login and passwords, to get the images from the container registries. So in terms of secrets that we'll try to detect today, we'll have the secrets used to connect to the API servers, and the secrets used to access the container registries. And then we have the components. So what are these components? So we can go deep into the documentation. So if you do a Google search, you'll have the same conclusion as me. You'll have this table with the components in Kubernetes. They all are TCP services with dedicated ports. We have one port for the API server, one port for kubelet, and so on. And the next question, that's my main initial question for the talk, are they exposed online? So obviously you can scan the internet yourself, or you can go to internet scanning platform like Shodan and Census. If you go to Census, you will get slightly different numbers because they don't count Kubernetes the same way, but by the end of the day you will have something like that. You will have some Kubernetes components exposed over the internet. The first one, 10,250, that's kubelet, and then you have the API server, 6443 and 443. Obviously like HTTPS server. The other ones, Kube scheduler and then Kube control manager, they are barely exposed on the internet. My explanation is that kubelet, that's something you deploy on a node, so at some point in time you need to talk to that over the internet, and API server just basically like your SSH access or console to Kubernetes, if I want to put that in simple words, so you need to connect to that. So people tend to expose that over the internet. One piece is missing on the slide is etcd. So what's going on with etcd? So again, another query to Shodan on top that just product etcd, just to list them. And we can quickly see that 4,000 instances are exposed. So at first I didn't know, is it good, is it bad? It's pretty much like really bad idea. There is something else in Shodan that is interesting, a bit small here on the slide. Shodan is able to give you the size of the database, so the content of the etcd instance. Basically means that Shodan is able to get the data without any authentication. And it's pretty bad, because Kubernetes uses etcd to store everything, store the object, deployment, the pods, even the secrets in plain text. So it's like the brain, or they call that the data store of Kubernetes. So it's likely a bad idea to have that connected online. Indeed, if you check the documentation of Kubernetes, it's basically written that access to etcd is equivalent to root permission in the cluster. So if you can write into etcd, bad things will happen. Some smart researcher for MCC Group, his name Luis Toro, did some indeed really cool stuff when it comes to pen testing etcd. He even developed a tool called kubeetcd, and the trick is, usually when you interact with Kubernetes, you will use a kubectl tool that will talk to the API server, and API server will inject some perfect Kubernetes object or well-formed object into etcd. And Luis, he wrote another tool called kubeetcd that talks directly to etcd. So it can do really bad stuff. Luis' scenario is a bit different. In this scenario, it was a pure pen test, so Luis is able to steal etcd credentials, which are TLS keys and TLS certificates. In my case, there is no authentication, so I can directly talk to etcd. And we show that it's possible to do many bad stuff, inject any object, read anything, in such a way that, for example, you can deploy a pod, which is an application deployment in Kubernetes, but real administrators won't be able to delete it, because the objects internally stored in etcd are malformed, and then the real tools are not able to delete them. And then, depending on your interest on red teaming and pen testing, you can do even bad stuff like popping a remote shell or actually doing your own deployment. Going back to the Shodan data, at first, Shodan said that is 4,000 etcd instance exposed. Then if you try to access them, you will briefly go to a smaller number, just 2,000 instances with keys. And then you have a lot of different things. Indeed, etcd is not only used by Kubernetes, it's used only by other projects like API 6, some time series database like TIDB, TimescaleDB. So you need to do a little bit of data inspection. At the end of the day, there is 14 instances that are likely related to Kubernetes. If you dig deeper in the data, you will find that there is only 9 etcds that are likely related to clusters. And one number that I think is really impressive, that 6 clusters manage more than 3 nodes. So it's not an experiment. It's not a toy project. It's getting bigger. So out there we have people with etcd exposed over the internet. So anyone can do code execution on them. And I will come back on that a bit later at the end of the talk with the responsible disclosures that I did. Takeaway messages. Please be careful when you deploy etcd. So my main takeaway that the last line, don't install Kubernetes yourself. So you can do it, but if you do it, you need to take care of the whole control plane security. So you should probably do that using cloud providers. Network isolation, you have flags in etcd just to make sure that specific IP addresses, specific clients will connect to etcd. That's something you should do. Avoid binding it to localhost, because then if you do a mistake with the network and firewall configuration, they will likely be exposed. Two other things, if you store secret in Kubernetes, and that's the best current practices, is to encrypt these secrets or to use an external vault in order not to have the secret in Kubernetes. And finally, something that I didn't know I discovered, if your etcd credentials are getting stolen, that's the end of the day, because there is no authorization model. So anyone can do anything with the secrets. So that's the end for the first part of the talk. So I will go and have a look at another component, which is the Kubernetes API server. And that time we'll indeed have a look at the leaked secrets. So what are the secrets that you can use in Kubernetes? That's all of these ones. And the two in green, the service account and the TLS credential, that's the one that are used to actually connect to the Kube API server. The TLS certificates are used by you and me, like users, regular people, admins usually. And the JSON Web Tokens, they are used, I will say by default, by services. For example, if you have GitHub action on GitHub, building a Docker image, then trying to do a deployment, you will likely manipulate a JSON Web Token. So it's just to automate things from machine to machine. People in my field call that NHI. That's a new term from last year, which means non-human identity. So basically, a computer. On the right side, you have an example of what we find, usually on GitHub and Docker Hub. So people are coding secrets in code. That's a kubeconfig file. You can think that it's like SSH config. That basically you define the server and the credentials. So here the credential, that's TLS key, and then the TLS certificate. You can use kubectl with this file, but there is other ways to interact with Kubernetes, and you can use curl, because the control plane components, like Kube API server, just a web service from the external world. First step is to convert this base64 strings into PEM, which is the format of keys and certificates. Then if you want to do a little more checks, you can check the modulus, if the modules are the same in the client key and the client certificate. And finally, you can use the credential with curl. That's super simple to connect and list the namespaces. Namespaces like some kind of ways to store your application. So Kubernetes people will likely yell at me, but I'm trying to oversimplify. In that case, I'm not specifying the server certificates. That's why I'm using insecure, because I just don't care. I don't need to speak to the real server. I don't care of the identity. I just want to get the data with the credential. So in that case, it just works. Some exploitation scenarios. If you want to dig into that, I will suggest you go there on the link. There was a really great presentation at Insomniac this year that explained what you can do with Kubernetes credential. In that example, I just assumed that we got really high privilege credentials, because that's the one I found on GitHub and Docker Hub. There is no, I will say least privilege. So all of them, or most of them, are able to do really bad stuff with a cluster. So you can do lateral movements. You can deploy new applications, which are called pods yourself. You can try to elevate your privilege on a real a virtual machine on a node to get physical access or a shell on the pod. You can do persistence by creating new accounts, service accounts, and then you can dump secrets. So that's what I like to do at GitGuide, dumping secrets and then do some lateral movements. This is an example that I found on Docker Hub. I really like. It's really explaining the way secrets propagate and how hard-coded secrets are dangerous. I found a JSON web token on Docker Hub in a Docker Hub image, so public Docker Hub image. The JSON web token was valid on a Kubernetes cluster. The Kubernetes cluster was indeed executing this image with other images. The Kubernetes cluster was also storing secret registries. And at the end of the day, these publicly exposed leaks, they lead to private Docker images being exposed, so an attackers can actually access those, backdoor them, and do even more bad stuff with the cluster. Briefly, talking about numbers, so we detected certificates and JSON web tokens hard-coded both on GitHub and Docker Hub. At the end of the day, that's 44 unique active clusters. In most of the situation, we have really high privileges on the clusters. 4 of them, they have more than 10 nodes, and 1 has more than 200 nodes. So it's like a beast. So we have access to 200 a node cluster, which is crazy stuff. With GitHub data, we're able to calculate the exposure time. So 30% of these active clusters from last week, they were exposed for more than 2 years, and 1 was exposed 4 years ago, almost 5, which is really, really bad. And trend that we see often with hard-coded secret, people will push a secret to GitHub or Docker Hub, realize that they did a mistake, and instead of revoking and rotating the secret, they would just delete the proof. So they delete the commit from GitHub, but still, only 10% of these hard-coded secrets were deleted. So they are still valid and in the wild. Another fun fact, the valid JWT were only seen on Docker Hub. I think I've seen only 1 on GitHub, which likely explain that the certificates are used by human. Human will actually, by mistake, hopefully, commit their kubeconfig into GitHub, and the JWT are used by machines, service accounts, and people don't put that on GitHub. That's my explanation. I don't really know why. Some takeaways, again, if you are into Kubernetes security, network isolation, so please don't expose Kubernetes clusters publicly. Use providers features to restrict that, Azure, AWS, all of them, they always, with one click, just to protect the API server. Please do logging and monitoring, check the access to your cluster as you do with SSH. Make sure that you are also alerting on suspicious activities by using a SIEM, for example. And if you must use public access, don't use long-lived credential. Go for something called short-lived tokens. You have a lot of access providers in Kubernetes called OIDC. You can bind it to AIM, AWS, Azure, AD, Okta, and in that case you will get short-lived tokens. So it means that if someone hardcodes credential on GitHub, the attack window is super small. And obviously don't do like these people, go for least privilege principle. So if you need, for example, to deploy application to a specific namespace, just give permission on this namespace and not on the whole cluster. It's really basic stuff. It's written in the Kubernetes documentation, but it seems that people don't do that. The final part is related to the Kubernetes container registries. Again, we'll have a look at the secrets. You have 2 types of secrets. One of them is called Docker CFG, and the other one, Docker config JSON. Docker CFG is at the legacy format, barely seen on GitHub, or at least when we detect them, there is no valid credential associated to that. And the other one, that's Docker config JSON. On the right, that's also the typical leak example that we find. We have a base64 encoded JSON file that you can obviously decode like this with the JQ command. And at the end of the day, we'll get something called auths or authorizations, which are a list of credentials for container registries. Some of these Docker config JSON, they contain more than one credential. So here in this example, we have a fake, obviously, credential for Docker Hub. The username is BlackAlps and the password is raclette. And a good reminder that good food, good cheese, is not a good password. So don't use it, please. When it comes to registries, what is the usual workflow? First, you will log in. So if you're lucky, you are using, I will call that, a registry which is compatible with the container API registry, like Docker Hub. So you just type Docker login, username, password, and that's it. If you are using other systems like AWS ECR or ACR on Azure, the endpoint for authentication is a bit different. So usually before or instead of doing Docker login, you will use the tool from the provider, the AZ, AWS. You will get a token, and the token will allow you to do something else, like reading from the registry, which is called pull with Docker, or pushing, which is writing. These one are standards. And then something else that you might be able to do with the credential, which is called enumeration, basically listing the images. And there is two tricks, two things different. One is standard. There is an endpoint called V2 catalog, and then it's provider dependent. And this dependence on the provider is super interesting because, and that's also why I have to confess I will like the registry secrets, because they both work. A secret works for the container registry and also for the underlying service. So for example, if you take a GitHub token, or if you take the GitHub container registry, GHCR, the token will work for the container registry, so you'll be able to pull and to push, so read and write Docker images, but also it will work on the platform. So the token is valid, you can list the user details, first name, last name, email, you can list the organization. In the case of Docker, GitHub, you can list the Git repositories. So one secret, several usages. And you have the same for Docker Hub. Docker Hub allows you to read and write images and also to retrieve information about a user. So it's really bad. And again, people, they don't really go for least privilege. So the secrets that I found are valid on both the container registry and the platform. Some exploitation scenarios. So in that case, I didn't find anything in the state of the art. So we can just try to find new attack vectors. The first one is the discovery. In that case, the attacker will try to access other Docker images, to enumerate Git repositories and private ones, which is indeed really bad. You go from one secret for Docker and then you go deep into a GitHub organization. You can do lateral movement, which is to compromise Docker images executed on the Kubernetes clusters and then trying to make your way to, for example, get node access. And then what I would like to do, get more and more credentials by digging into the data you found in the private registries. Just a slide with small numbers, data again from GitHub and Docker Hub. We found 4,000 auths, which are the authentication strings, in there. There is half, 2,000 that called resolved. What is resolved is like when you do DNS resolution, meaning that it's possible to reach the final destination. So in between, we have 2,000 half that are likely not reachable anymore, or they are likely private registries. And then there is a breakdown of the services, 1,000 Docker Hub, 500 GitHub, and so on. At the end of the day, if you try to validate this credential, 46% are valid, which is a really big number if we compare the number of valid certificates and GWT. And few takeaway messages on that. We managed to discover 300 private Docker Hub images, so things that are not supposed to be publicly exposed. So something a bit more shocking, that with this GitHub credential, it's possible to get access to private Git repositories, so not Docker, means something else, and it's really bad. And some leaks are really old as 4 years old, or soon. Takeaway message from this part, so avoid using public container registries, or at least don't store private information into public registries that don't mix really well. Please try to use least privileged credential. You only want your Kubernetes cluster to be able to read and pull images. You don't need them to write. You don't need them to list. However, it's not possible with GitHub. From the GitHub documentation, it's written that you need to use something called the GitHub private access tokens, and they are full privilege. So it means that if you are using GitHub container registries, it's really bad if your tokens are being exfiltrated, leaked, stolen, and so on, because you will give access to everything you own on GitHub with this token. Another thing that I really like, the registry's credential, they seem to outlive the Kubernetes clusters. It's like people are doing deployments, testing cluster and so on, but they just forgot to revoke and to remove and rotate the Docker registry's credential. So please revoke them when the cluster is decommissioned. So last 2 slides. So I took days, maybe weeks, doing disclosures. At the end of the day, I managed to contact 16 different companies by using different tricks like using the pod names, the host names, the email addresses from the Kubernetes configuration. Regarding etcd, I managed to identify 4 owners. Unfortunately, like it's usually the case when you disclosures, 2 contacts were invalid, and I'm still waiting for 2 answers, which slightly mean that these clusters are not used anymore, or at least I don't know more. Kubernetes API server, I managed to identify 7 different owners, and I'm still waiting for 3 pending answers. Recall that one of these clusters is really huge, with more than 200 nodes, so it's a really big company behind. I'm still waiting for them to acknowledge. And on the container registries, I managed to identify 4 owners, and and I'm still waiting for 1 answer. So this is targeting companies. So what we do at GitGuardian, every time we detect a secret on public GitHub, we'll send an email to the developer. So that was done before, but still, we know that we actually reach out to developers that have been leaking the secrets, but still, these are valid. So that's why I decided to go after the companies and make them fix everything. Last slide, final thoughts to the leaks. Kubernetes secrets, they are diverse. The misconfiguration makes them worse, so please apply the Kubernetes security best current practices. Some more takeaways, which are called the post-Racklet checklist, limit the exposure of Kubernetes components, enforce short-lived credential, use private container registries, rotate your leak secrets, obviously audit your images for hard-coded secrets, and please implement something called a well-known security.txt, which is really helpful for security researchers like me that are trying to do disclosures. And my last word will be image on the right. If you don't care about secrets, if you don't like Kubernetes, there is really one important thing to go home with. The Racklet emoji will never happen. I'm sorry for that. There is two journalists from a French newspaper called Le Monde that tried to have the Racklet emoji submitted, but they were denied access to the emoji world. So that is my last slide. If you have any question, let me know.
Thank you, Guillaume. You're perfect on timing. Thank you. We still have a few minutes for questions. Is there anyone asking something or commenting? Oh, please.
So you said you found these credentials. Did you follow up with the credentials to see if they're valid, or did you just take them at face value?
Which ones?
The ones that you found.
In where? Everywhere?
Yes.
These ones, for example?
The ones where you contacted the owners.
They were valid.
How do you know?
Because we test them.
Is that a problem?
So far, no. And I think it's not, and obviously I think it's not for one good reason, is that that's usually in scope of bounty programs. Side joke. And also that's what people need when it comes to secrets. There is a lot of hard-coded secrets, so that's what we do for a living, so we detect plenty of them. A bunch of them are invalid, and our customer, they want us to actually validate, because that's how you can actually triage them and not don't know what to do with them. And when we test a secret, we don't pull all of the data. That's what I did for some parts, because at some point I need to know if it was possible to identify the owner. So most of these secrets I was only checking with, I will say try to retrieve the least amount of information as possible, just to validate. So in some case, if you go back for the curl command line, oops. What did I do? For the command line, in that case, what you can do, you can use --head. --head will not retrieve any data. That will just actually validate that you are allowed to get the namespaces. So we will not get data, but you will know if it's 200 status code or not. So it basically depends on the data you retrieve. And obviously if you get like personal information, email address, phone numbers, that's another story. But that we don't do.
Yes, another question just behind you.
Thank you. So in light of the last question, so you're accessing private data, basically. What did the legal team is saying about that?
No, which private data?
Well, you're accessing their infrastructure?
No, I'm just checking if the secrets are valid.
Well, you just said that you had to access.
For these ones where I didn't know who to reach, yes. In some cases, it was asked by the bounty programs.
Okay.
So the super, I will say the worst command that I executed on a cluster were actually asked by the bounty programs.
Okay.
And the guy said, "Oh, do you know it's us?" I say, "Yeah, because I have this information with the information from the Git commit, for example, or information from the host name." And then they say, "Okay, please, can you confirm that it's high privilege credential? Can you type the kubectl auth? It's not who am I?" Something like that.
Okay. It's just that you're doing the good thing, basically, but I was wondering of the legal implications of having to do that.
In the case of responsible disclosure, the legal team said it's okay. Obviously, if it's just to get the data, I do nothing with it, there is definitely something bad. But our goal is just to contact the companies and make these numbers decrease. And that's, again, takes a lot of time to do that and to get there. I mean, obviously, like trying to validate the secret, that's fast. Trying to find that and go there, that's weeks of work. And finger crossed, that will be fixed. That's really my hope. And with zero money for bounty.
Okay, it seems that no one else have any other question in the room. So, congrats again. Thank you for your talk.